right, welcome back. You've had some time to practice learning about increasing and decreasing intervals without looking at the graph. And we're going to keep working with that, how to identify increasing and decreasing intervals without looking at the original graph, but we are going to look at the derivative graph today. And so that's going to impact, we're going to learn how to read a derivative graph, because you read a derivative graph differently than you read a regular graph. So we're going to look at a derivative graph, how to find increasing and decreasing intervals from that, and how to create derivative graphs with our calculator. So you should have your calculator handy because we will be needing that. Okay, so let's take a look at, this is an original graph. All right, and this is the easier way to identify original graph. We know that there is a max here, and at a max it has a horizontal tangent, so the derivative is equal to 0. And so when we draw a derivative graph, we translate directly below that and we put a 0 on the derivative graph. Okay, so a max on the original graph, where the derivative is horizontal, would be drawn as a 0 on the x-axis of the derivative graph. Similarly, we have a min, also where f prime of x is equal to 0, and so we draw that directly as a 0 on the x-axis also. And so the first thing you do is identify on an original the maxes and the mins, and those turn into zeros on the x-axis. Then we look at the increasing and the decreasing. And so a max has increasing parts of its graph, positive slope, and then decreasing parts of its slope on the other side. And so when we drop those down, we're going to put a plus above the x-axis and a minus below the x-axis. So that means when you draw something, it has to cross from top to bottom. Okay, it has to cross from the plus side of the x-axis to the minus side of the x-axis. Then going over to our minimum, we go from a minus slope, a decreasing, and we switch to an increasing, a positive. And so when we drop that down, we'll go from a minus to a plus, and so we'll cross that way, okay, crossing from below the x-axis to above. And then we connect those like this, and just kind of extend it a little bit, and that is the graph of a derivative. So that is starting from an original graph and creating a derivative graph. Okay, finding the maxes or mins, dropping them down onto the x-axis, and then turning plus and minus slopes and dropping those down onto the x-axis as well. Okay, now do it backwards. Okay, here is a derivative graph, and we want to go the other way. So you start by looking at the places where it crosses the x-axis. Okay, and it's crossing the x-axis in such a way that it's going from a plus to a minus. Oops. Okay, there to a minus. That means that the original graph that you have to create has to be a max going from increasing to decreasing. So we'll kind of take this up here, and we're going to make a max that's going to go from increasing to decreasing. All right, now we find the next 0, the place where it crosses the x-axis, and it's crossing in such a way that it's going from minus to plus. So that means you pull it up, and it's going to be a min going from negative to positive, a minus to a plus, decreasing to increasing. Then you move over to your next 0. It's going from a minus to a plus. which means it's going to be a max, going from a positive to a negative. And then your last one where it crosses the x-axis, it's crossing going from a minus to a plus, which means it will translate into something that's going from a decreasing to an increasing. So that's where all the maxes and the mins are. And then you just have to connect it so it's continuous. And then add the ends to it. And now you have a graph of the original. So that skill of being able to go from an original to a derivative or a derivative to an original is going to be hugely important in what you take away from today's lesson. So let's summarize that. The most important parts of a derivative graph are the places where it crosses the x-axis. Okay, each of those places where it crosses the x-axis is going to turn into either a max or a min. So when the derivative graph crosses the x-axis with negative slope, then the original graph, okay, will have a local maximum with a negative curve. Okay, so negative slope translates into a negative curve like this, which means a max sitting on the top. And when a derivative graph crosses the x-axis with positive slope, then the original graph will have a local minimum with a positive curve to it like this. And so now we'll have a minimum there. Okay, so again, the most important part are the places where it crosses the x-axis. Okay, you just focus in on those places where the derivative graph crosses the x-axis. So let's practice that again. Where does this derivative graph cross the x-axis? Okay, it crosses the x-axis here with a positive slope. Okay, going from negative values to positive values, that's a positive slope. That means this will have a positive curve with a minimum value. So just kind of looking up here, a positive curve to it, a minimum value, decreasing, changing to increasing. So the next most important point is right here, okay, just before 3. And this time it's changing from positive to negative. It's got a negative slope. Okay, a negative slope means that you've got a negative curve with a max on it. So it'll be like this, a negatively curving down, but with a max. The next most important point is right here, not quite 5.5. Changing from a minus to a plus, that's got positive slope. Positive slope means positive curve, so a positive curve to it with a minimum. So those are the most important points, those 3 points. The other stuff, like what's going on here and what's going on here, those are kind of meant to, not necessarily throw you off, but you have to focus on are these most important points here, these 3 most important points. And then if you want to try and connect it, you can connect it in more of a smooth way. Okay, we can make the connection so it kind of looks like this and connects. And then maybe we can sort of connect these other 2 pieces and it can come down and connect. And then the rest would be going up like that. Okay, so just a possibility. So we've got a local min, another local min, and a local max. All right, what's the second most important part of a derivative? Okay, so the first most important parts of a derivative graph are the places it crosses the x-axis. The second most important parts of a derivative graph are the places where it is maybe broken or discontinuous. Okay, a broken or a discontinuous part of the derivative graph. So when it's broken into two pieces, if the pieces change from positive to negative, okay, again, positive to negative, then it will mean I have a local max, this time with a negative corner or a negative cusp to it. Okay, a local max, only it's still going to have a corner like that. So like a negative corner. It's a max with a negative corner. Or maybe it's a cusp like this. Okay, the negative cusp, the cusp part of it is opening downwards. When the pieces of the graph change from a negative to positive, then the original graph will have a local min with a positive corner or cusp. So maybe the corner looks like this. Okay, the corner is opening in a positive way, or the cusp is opening in a positive way, like that. So here's a graph that is broken. It's broken at 0, but it's broken where there's a positive piece here above the x-axis and a negative piece. So that's positive to negative. Positive to negative means increasing to decreasing. So that would be a max. With an opening downward. Okay, a corner opening downward, or it could maybe look like that. All right, so let's take a look at all of these. Now, the first most important points of this derivative. Okay, here is a derivative graph. This is an important point. It's identified as a local max because the values are from plus to minus. Okay, I always look at like what's first. If it's a plus first, plus to minus, plus means it's going to be a max. That's what I always do. Okay, plus first means it's going to be a max. This other point is also important. Minus to plus, okay, below the x-axis to above. The minus comes first, so it's going to be a min. But what about this point right here? Isn't that an important point too? Well, maybe, except it's minus below the x-axis, and then it's still minus below the x-axis. And when it doesn't change like that, when it's a minus to minus, that's not a min or a max at all. That's neither. So you might, you might see that, but it has to be something that changes from one to the other. So this plus section right here means the original function was increasing up to that point. And this plus section right here also means the original graph is increasing at that point. And the whole rest of the derivative graph is all minus below the x-axis, and so it is all a decreasing interval. So we see it is increasing for every x that's less than -2. And it's also increasing for every x that's greater than 4. But it is decreasing for every x that's between -2 and +4. All right, so between the places where a derivative graph crosses the x-axis, we can learn whether the original graph is rising or increasing, or falling or decreasing. But it has to cross, okay? It has to cross the x-axis. All right, now we can get a peek at graphs also by looking at derivative graphs on our graphing calculator. Okay, so I'm going to teach you how to do that. So please grab out your graphing calculator. And you need to have a good window. So start with a standard window. So the window could be, you know, -10 to 10, both x and y, and that should be fine. All right, then you're going to put your function into y1. All right, so you are going to start with your standard window, and then you're going to go to your y1 and you'll enter your function right there, whatever the function is, whatever you're given. So let's do an easy function and we'll just do x squared. Okay, then you're going to put the derivative command into y2. So go down to y2, and this is now under math 8. So hit the math 8 button. Whoops, let me clear that. Hit the math button, and then go all the way down, scroll down to option number 8, and you see how it says derivative. All right, so pick math 8, pick that option, and then you should have the following in. If you don't, please take a screenshot of what your calculator looks like if you have an older model of the calculator, so that I can tell you what you need to type in there, okay? But what you need to put in is, in that denominator, you'll put an x. In the parentheses, you need to put y1. So we want to make the derivative of what we put into y1. So the way you get to that is to use your vars key, okay? Vars is right here next to clear, so pick vars. Go over to the y vars options, which is the second menu. Pick function, enter, and then put y1. And that puts y1 into the parentheses. And then over at the end, you're going to fill in x there also. So x goes in two places and y1 goes in the middle. All right, and then the calculator knows that you want to graph the derivative. Now right now it's set to graph two things. See how both of these are highlighted? You want to just graph the derivative. So go back into your y1 and put your cursor on top of the equal sign. So it's blinking right now, and hit enter while it's sitting there. And then what that does is it unhighlights that one so that your calculator isn't trying to graph two things at the same time. It'll only be graphing one thing. And then if you hit graph, you should see the derivative graph of the function that you put in to x1. So here is what you should see if you did it correctly. All right, that was just a practice one, okay? All right. Okay, so we are going to now do a more complex function, and we're going to take a look at the derivative. So for the endpoint, we need to think about the domain. Since the domain is all real numbers, we do not have any endpoints. For our critical points, we are going to have the calculator draw a derivative graph for us, and we want to find where the derivative graph crosses the x-axis. Okay. Find where f prime of x crosses the x-axis or is broken. Those are the two places, okay? Crosses the x-axis or is broken. All right, and we're going to do this with our calculator. All right, so why don't you pause the recording until you've had a chance to enter it. And then once you enter it, make sure that you unhighlight that y1, okay? Don't erase it, just unhighlight it so that when you're looking at the graph, you don't get you know, two graphs at the same time, just one. Okay, so this is what the derivative graph looks like in a standard window. I'm going to zoom and do a zoom in option, number 2, so that I can get a little bit of a closer look. I hit enter on the origin. And so it's going to be graphing it so I could just have a little bit of a closer look. And remember, I want to know where it is crossing the x-axis. Okay, not just touching, but completely crossing the x-axis. Okay, so what I would like you to do is sketch that as part of your notes so that you've got a visual recorded. All right, don't just, or you know what, I wouldn't even mind if you took a screenshot of your calculator and put that into your homework too. That would be fine. All right, so right beneath here, I'll do a quick sketch. So I saw it cross the x-axis and then come back down, and then I see it touch the x-axis but not cross, and then back up again. So the most important parts of this graph are the places here where it is crossing the x-axis. Okay, this part right here, not so important to me because it did not cross the x-axis. All right, this crossed at the number 1. Excuse me, it looks like -1. So in my chart here, I'm going to set up from x is -1, and then from -1 up to, in the next place. Now it's crossing at a decimal value, so I'll need to use a calculate 0 to find out exactly what that value is. Okay, let me remind you how to do that. So second trace, not just trace, but second trace. And I want to calculate the 0, which is option number 2. And I am looking for this point right here. So I need to make sure to set a marker to the left of it and to the right of it. So I'm going to move my little cursor. Here comes my little cursor, and I want to make sure I'm right above it. So that's a positive number. And then I'm going to move my cursor right below it. That's a negative number. And then I want to be as close to 2 on it for my guess. And it tells me, as it's figuring it out right here, that it's -0.2807, which is -0.281. So let me mark that here. -0.281. Okay, so then the next one would be -0.281 up until the next place where it crosses the x-axis, which we're going to skip the place where it just bounced off, and we want to go to that very last one. So I'm going to do a second trace to find that. All right, and I just did it, and it turned out to be 1.781. So I'm going to have to squeeze all of these in here, 1.781, and then shoot, my last one would be x is greater than 1.781. Okay, and then I put pluses and minuses in my chart. So this is going from a minus to a plus section. So there's a minus, and then there's a plus, and the next one goes from a plus to a minus, and then it stays a minus, and then it finally goes to a plus section. So now I read my my chart, and I know that what the original function is doing. Remember, what I am looking at is the derivative. I'm not looking at the original. I'm only looking at the derivative. But now I know what the original is doing. The original is decreasing first, and then it has a section of increasing. And so that change means that when I change from decreasing to increasing, I have a local min. And then I've got a decreasing section again, and so that change means I will have a local max. And then I'll have an increasing section again, so that change means I'll have another local min. Every time it changes from decreasing to increasing, from a negative section to a positive section, you'll have a local min, and the other way around too. Okay, let's try another one. Okay, do we have endpoints for here? Well, I do have an implied domain, and the implied domain has a square root. And so the implied domain says that the square root can never be negative. It always has to be greater than or equal to 0. And when I solve that, okay, when I do the math on both sides for that, okay, it turns out that x has to be greater than or equal to plus or minus 2, which means greater than 2 but less than or equal to negative 2, the negative one, the sign turns around. So those are my endpoints. I have plus or minus 2. Okay, now are there any other critical points? So I'm going to have the less than negative 2 section. Okay. Oh, we want to set the derivative, f prime, and we'll do a math 8, and find where it crosses the x-axis. So find f prime of x crosses the x-axis or is broken. All right, so let's do a math 8 on that one. Let me turn my video on here. All right, so I've put this equation into y1. I've unhighlighted it and double check my window. My window's back to normal. And so now I'm ready to graph. And here is the graph of the derivative. Now we notice that this never crosses the x-axis, but it is certainly broken. And it is broken between negative 2 and positive 2. It's not connected. Okay, there's a disconnect there. And so that's important for our equation 2. All right, so let me add that to my chart. And so we've got the section x greater than or equal to positive 2. Now this is above the x-axis. It's a positive because the thing I'm looking at is above. And it still is above the x-axis. That means I have increasing followed by another increasing, which means there's no max, there's no min, because there was no change, right? The change is not happening from a positive to a negative or negative to positive. It stays increasing the whole time. All right, find the absolute maxes and mins of this equation. Are there endpoints to this one? So we've got a similar implied domain situation here because of the square root. And so I'm not going to do the math again on that, but we've got plus or minus 2, again, being important. Now we want to find the derivative and find if the derivative crosses the x-axis or is broken. All right, so let's take a look at that. All right, so I've got my new equation put into y1. I am going to unhighlight the equal sign. My window is normal, so I'm ready to press graph. And I'm looking to see where this thing might cross the x-axis or it might be broken. All right, so I see something interesting going on, looking like it might cross the x-axis at the origin. So I'm going to zoom in on that and just check it out a little bit more. Okay, zoom in, hit enter. I'm going to take a closer look at that. And it sure looks like it's crossing that x-axis. So again, you can screenshot what you see or you can draw a sketch of what you see also. All right, so my sketch here. Seeing that it comes like this, and this is a derivative sketch, and it's changing from a minus to a plus. All right, so we've got from negative 2 Remember, that was part of the implied domain. Up until now 0 is where it looks like it crosses, and then from 0 up until 2 looks like that's where it's crossing, and it's going from a minus to a plus, from a minus section below the x-axis to a plus. So this is a decreasing to an increasing section, which means if we change from decreasing to increasing, that we have a local min at x is 0 because of the way that graph is changing. Okay, we know about the what the original graph is doing. Okay, one more here. We have no endpoints because there is no denominator, there is no even radical, there's no logarithm, so my endpoints here are none because we have all real numbers. We want to check, we're going to set up the derivative, and we want to know, does it cross the x-axis or is it broken? Okay, I have my original function into y1. Let me unhighlight that. I already know that my window is set to standard, so I'm ready to take a look at the graph. Oh no, you know what? I had zoomed in last time, so I forgot to check that my window was back to standard. So I'm going to have to put my window back to standard here as soon as it's finished. Okay, it's finished drawing. Let me go back to a zoom standard here. I'm looking for places where it crosses the x-axis and where it might be broken. So it appears to be a little bit broken at the origin, or at 0 along the y-axis, and then it crosses the x-axis again. Okay, so you know what? I'm going to zoom back in on that. That was interesting to me. Okay, so look, I'm going to watch it, and it is going to come down and then be broken at an asymptote, and then come and cross the x-axis there, and then cross over. All right, good to know. All right, so a quick sketch of what I see here. I see it coming down and being broken, and then coming back up and then crossing the x-axis. So that broken place is at 0. So I'm going to set up x less than 0. And then where does that cross the x-axis? So I'm going to do a second trace to find out that value. All right, turns out by second trace that it ends up crossing at 0.5. All right, so then we've got from 0 to 0.5 and then greater than 0.5. And we see that this section is a minus, it's below the x-axis. And this next little section is a minus also, it's below the x-axis. And then we have a plus, so we've got a minus followed by a minus and then a plus. So we have a decreasing interval followed by a decreasing interval, so no change. And then we have an increasing interval, which means we have a local, what kind? A local min at x equals 0.5, because I'm changing from a minus to a plus, which means I'm changing from a decreasing value to an increasing value, which creates a minimum. Okay, so let's say that you're given a graph and you're asked to read this. Okay, remember, you're looking at a graph of the derivative, and the most important parts of the graph of the derivative are where it either crosses the x-axis or is broken. And so we see that it crosses the x-axis at -2, and it crosses the x-axis at +2. It does not cross the x-axis at 0. The way in which it crosses the x-axis is from a positive to a negative. And so a plus to a minus indicates the presence of a max. So we know that our max is at -2. And then the next place it crosses is from a minus to a plus, and that identifies a min. And so that would be happening at positive 2. And so the intervals where this is rising are the places where we have a plus interval. And so rising would be x less than negative 2, and also x greater than positive 2. And the decreasing intervals are between both of those. So between negative 2 and 2 is where the original graph would be falling or decreasing. Okay, we're going to skip this one. We're going to come back to that. Okay, and then here, again, most important places are where it crosses the x-axis or is broken. So it crosses the x-axis here and here and here, but it's also broken right here and disconnected at F. Okay, so then what's happening on those? Well, this is a minus to a plus change. And that minus to plus means I have a min, so I have a min at A. And then the next place is changing from a plus to a minus. That's a max, so I have a max at C. And then E is a minus to a plus. Okay, below the x-axis to above the x-axis, that's another min, so I'm going to add that to the list. Around the brokenness, it's a plus and another plus. They have different directions, but they're both above the x-axis, so that's considered a plus. Anything above the x-axis is considered a plus. So that's nothing. It's no change. And then the G is a plus to a minus, above to below, so that's a max, so that is G. So then where is it increasing? Well, it's increasing anywhere that I've written plus signs. So that means from A all the way to C, and then again from E to F, because there's plus signs in there, and again from the letter F to the letter G. And the decreasing are anywhere I've put a minus sign, so anything that's less than A, anything from C all the way to E, that's all minus signs. C, D, and E are all minus. And then anything after G, so X is greater than G. And those are your maximum, rising, and falling. And then we're going to skip this last one. We'll talk about that at a later date. Okay, so you will have a couple different things. One, they will draw the graph for you and ask you questions like I just did, like these exact last ones. Or two, you will have to create a graph using a Math 8 yourself and then answer the questions yourself. Okay, so those are the two kinds of questions. It's all about reading a graph. Remember, your most important things you're looking for are where it crosses the x-axis or is broken. All right, good luck with that, and don't forget to sign up for Friday if you want some extra help.